Okay, let me talk to you a little bit in depth about the second circle we looked at, because I was running out of a bit of time in the last clip. Right, like I said to you, if you take one of the circles that it's one of the triangles we discussed before, the one where you had 2, root 3 and 1, and you halved each side, you get this triangle, right? And I said to you, you can these particular coordinates are actually made from this triangle here. And let's discuss one of the coordinates right now. Okay, so let's discuss this coordinate here. Okay, well, if you look at this coordinate, it's made by this right angle triangle, right? And it's actually this blue one, where this is the side 1. Okay, there's side 1. There's the right angle. Okay, this would be the length of a half. And then this length would be root 3 over 2. Okay, that would be root 3 over 2. But if you think about the coordinate, if you start at the origin, you're going left and up, that means the coordinate has got to be minus root 3 over 2 to go left, and then up a half. So that's where this particular coordinates come from. But we can also discuss the angles which are made as well. So we can also discuss what is this large angle here? This large angle theta, because cos of that green angle theta would be the x component here. This would give you the minus root 3 over 2. Okay, that would be the x component. So this green angle here would actually result in this particular x component. Okay, but let's try and work out what that particular angle is. And it's really to do with these here. So if we discuss those angles, first of all, let's look at this triangle here. This triangle, this green one, is identical to the one I rubbed out here, and then this angle will be the smaller of the two, so this would be your pi over 6. Okay, that would be a pi over 6. And like I said, this triangle here before is the same triangle now, just identical to this blue one. Just plot here, there's your side 1, there's your 90, and I'm going to draw it in, let's say red, and I'm going to make it a little bit thicker pen. Okay, this red angle here, this red one would be your angle here. That would be pi over 3. This red one, this would be pi over 3. Okay, but then what would be this tiny blue one here? Okay, what would be this? Sorry, this pink one here. What would be that angle there? Well, we know this angle is pi over 6. We know that's pi over 3. You just need to subtract them. So pi over 3 take away pi over 6. That will tell me what this little gap here is. Okay, and then if we subtract them, okay, I can double this one. So 2 pi over 6 take away pi over 6. Well, that's just pi over 6. Okay, so that take away that gives you pi over 6. This angle here is pi over 6, and then so is this one, so is this one, so is this one, this one, this one, this one, this one, this one, and this one, and they're all these little ones here. Okay, let me rub all of this out. All these kind of little kind of sectors here. That's pi over 6. This is pi over 6. So is this, and on all of them. So if we go back to this particular coordinate, okay, the one with what we discussed here, this particular coordinate, what is this angle? What's that angle? What's this angle theta that gives you minus root 3 over 2? Okay, well, let's work it out. Okay, these are all pi over 6. We've got 1, 2, 3, 4, 5 pi over 6. So there's 5 pi over 6. And if you check that out, that will give you minus root 3 over 2. So let's actually work that out. So let's do, first of all, cos of 5 pi over 6, and press enter on that. We should get a minus number. We do, minus 0.866. Okay, now let's work out minus root 3 over 2, so control divide, so that's our minus root 3 over 2, and we should get the same number. Yes, we do. Okay, that works. So someone said to you now, what is cos of, no, what's not, let's see. What is sine of 5 pi over 6? Okay, then that would have to be the y component. That'll be half. Okay, and let's just double check that. So, oops, no, don't want to do that. I just want to press trig. Sine 5 pi over 6. This should be a half. It is. Okay, right, now let's just look at some more examples to do with this. Okay, let me rub all of this stuff out. Okay, so let's look at some more to do with this circle. Right, what if you were asked to work out this? Work out the following. Work out cos 2 pi over 3 without a calculator? What would that be? Okay, now, well, if you think about it, we're working I said to you, all these little sections are in pi over 6. So you need to recognize that this 2 pi over 3, okay, well, if you ignore the pi for now, that fraction we can easily change it over to 6. We can change it by doubling it. We get 4 pi over 6, right? 4 pi over 6. So all we need to do is count 4 pi's over 6. So we've got 1, 2, 3, 4. So we're dealing with this coordinate, and then the x component is to cos of that angle. So cos of 4 pi over 6, and what does it tell you? It's minus a half. So that's automatically minus a half. Okay. If you want to check it, so we've just worked out. Oops, no, I don't want to do that. Delete all this. Okay, so cos of 4. Okay, now what was it originally? It was 2 pi over 3, right? Sorry, over 3, wasn't it, right? So let's check our original one, and we get minus a half, just like we predicted, minus a half. Okay. Now you could also work backwards. If someone said to you cos of some angle equals, I don't know, let's say it equals a half, right? Okay, so it equals a half. But if you knew this triangle, okay, cos represents the x component, remember? Okay, so what we're trying to do is find out which coordinate gives us something where the x component is a half. And let's see, okay, well, that one's out of the question, that's minus a half. That one's root 3 over 2. No, that's minus 1. Not that one, that's minus again. Okay, there's one. Okay, there's one, that's a half. And there's another one, that's also a half. Okay, so we're going to look at, okay, starting from, remember, we're always starting from the x-axis, going in anti-clockwise fashion. What is the angle that gives you, so what angle gives you a half when you do the cosine of it? Well, okay, there's the first one. Okay, so we've got 2 pi over 6. Okay, there's each one of these, each one, that's 1 pi, and that's pi over 6, there's another one. So we've got 2 pi over 6. Okay, does that simplify? Yes, it simplifies to pi over 3. Okay, there's one answer. Okay, and then going anti-clockwise right the way around to the second coordinate. Okay, the second one. Okay, we just got to count how many pi's over 6 we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 pi over 6. Okay, and that simplifies to, okay, 2 goes into both of them. Goes in 5 over 3. Now let's just check that. Okay, let's just check it. Let's just check it out. So cos of 5 pi over 3, does it give us a half? It should do. Alright, so cos 5 pi over 3, press enter, yeah, it does give us a half. Okay, it gives us half exactly, so we know it's that. Alright, let's do one more. What if someone said to you sine of some angle equals minus root 3 over 2? Okay, minus root 3 over 2. What's that angle got to be? Okay, so remember, sine is to do with the y component of the coordinates in the unit circle. So let me go about all of these. Okay, so we're looking for the y component. We're looking for the y component that is minus root 3 over 2. Okay, so let's see, that one's out of the question. This one's also out of the question. That's a half. Nope. 0. Nope. Nope. Okay, here's one. Okay, so this coordinate. Okay, there's minus root 3 over 2, and lo and behold, there's the other one. Okay, so minus root 3 over 2. So let's see. Okay, we're going around the circle. We could also go in the negative direction as well. Maybe we wanted theta to be a negative, so we could go down to quickly get to this one and that one if you wanted. But we should go anti-clockwise round to this first one. Okay, let's count 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 pi over 6. Okay, which simplifies to 4 pi over 3. Okay, that's one answer for theta. Okay, and then the next one, okay, let me rub all that out again. So the next one is this coordinate. So going to this line, starting the x-axis, going round. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Have I got the right coordinate? Yeah, 10, so it's 10 pi over 6, which simplifies to 5 pi over 3. Okay, if you were to check that out, that would definitely give you minus root 3 over 2. Okay, right. We're going to look at one more to do with tan. Okay, to do with tan. Okay, let me clear all this out. Okay, let me clear all this out. Okay. Okay, we need to go to our original circle. We're going to do one more with tan. Okay, so we'll go to this circle here. Okay, to do with root 2. Now, remember, tan can be written, tan of something equals the same as doing sine of the same thing divided by cos of something, okay? And remember the all silly turtles crawl business, okay? Because that's going to help you to locate the particular angle when you're dealing with tan, first of all, right? Now, let's say we wanted to work out tan of, well, let's say tan of something equals 1. Okay, tan of something equals 1. Now, if you think about the fraction, okay, if you think about something being divided by something else equaling 1, okay, some number divided by some number equals 1, it has to be the same number on top divided by, so it'd have to be like something over something, right? Okay, and also tan's positive, yeah? This is positive 1, so where was tan positive? Tan was positive here and here. But if you look at these two coordinates here, okay, 1 over root 2, 1 over root 2, okay, that's the cos of the angle, that's sine of this angle, theta, right? So if you take them and divide them by each other, they're the same number. If I divide that number by that, this one divided by that one, I get 1, right? So this is the angle theta I'm looking for. And what's that angle there? That was pi over 4 on this circle, so theta could equal pi over 4. There's one answer, okay? But then if you look at this coordinate, okay, this coordinate here, minus 1 over root 2 and minus 1 over 2, there's your cos, there's your sine. If you divide that one by that one, you also get 1. 2 minuses make a plus, so minus divided by minus is plus. So then this angle going all the way around is another one. Okay, so theta could equal that large angle as well. So these are all pi over 4, these are all 45 degrees. 1, 2, 3, 4, 5. So you've got 5 pi over 4. Okay, and if you check that out on the calculator, if you actually did tan of 5 pi over 4 and press enter, you get 1. Okay, so you get 1. And but then if you think about what these two would be, okay, if you take this one and divide it by that one, divided by that one, you'd get minus 1. So if I was looking for tan of something equaling minus 1, I'd be looking at that coordinate. And the same thing here, if I took this one here, which is negative, divided by this one, I'd get minus 1. So these two would give you the minus 1s, okay, for tan, and these two would give you 1 for tan. Okay, alright, let's just do one more on this particular one here. Okay, now, same thing, let's say I'm looking for tan some angle to equal root 3. Okay, now same thing applies. Okay, remember this is the cos of an angle, this is sine of an angle, right? And tan is equal to sine divided by cos. Okay, so if I take this, I'm looking for coordinates where if I take this component and divide it by that component, I get root 3. Now where does that happen? Which coordinates does it happen for? Okay, so well, okay, I kind of pointed it to the obvious one. It happens definitely for this component. If I did root 3 over 2 divided by a half, okay, remember how you divide by fractions, you keep the first one the same, change it to a times, and you flip the other one. That gives me root 3. Okay, so there's one, and it's a positive root 3, okay, so I'm only looking in this corner and also this corner as well, because that's I've got a positive root 3, right? All silly turtles crawl. Right, so there's one coordinate. Okay, so I'm looking for this large angle, and what's that large angle? So I've got 2 lots of pi over 6, which is pi over 3. So theta could equal pi over 3. And with the tan function, really, it's kind of they're in sort of, they correspond to each other. So if you find this one, the opposite line across from it, that's the other one as well. If I take that and divide it by that, I also get root 3. So this is the second answer as well, this large angle here. Okay, and what is that large angle? I'm just going to stop it because it's going to run out of time.